In this video, we're going to look at the processes of oxidation and reduction and how we can use those to assign the terms oxidizing agent and reducing agent to species in a reaction. To understand oxidizing and reducing agents, we first need to understand what oxidation and reduction are. And we're going to use a pretty simple memory device for this, and that memory device is going to be Leo, L-E-O, the lion, says Ger, G-E-R. So this is Leo, ferocious lion. And Leo the lion says Ger stands for lose electrons, oxidize or oxidation, and Ger stands for gain electrons, reduction. So when we talk about losing and gaining electrons, we're talking about half reactions. So in an oxidation half reaction, we are going to see a substance, and we'll write the half reactions for copper here. So we're going to see a substance, copper, lose electrons. So when copper oxidizes, it goes from copper solid to copper 2+, because it loses 2 electrons. So when we see electrons as a product in our balanced reaction, that's a loss. You'll notice in our balanced reaction that the charge is equal on both sides of the reaction. So on the reactant side, we have an overall charge of 0 because we have an element. On our product side, we also have an overall charge of 0 because we have 2+ from our copper ion and 2 electrons gives us overall 0. So that would be an oxidation half reaction. A reduction half reaction is going to be the exact opposite. So if we're talking about a metal, we'll look at copper again. We typically will start with the ion, and that ion will gain electrons to form the element. So in this case, the gained electrons will be a reactant. And once again, we have an overall charge equal on both sides of the reaction. So a net charge of 0 on both sides of the reaction here. So for looking at an oxidation reaction, typically we can just look at where the electrons fall. So in an oxidation reaction, electrons will be a product on the right side of the equation. In a reduction reaction, electrons will be a reactant. The other thing we want to look for is the charge on the elements. In an oxidation reaction, the product is going to have a higher charge or a more positive charge than the reactant. We call this charge the oxidation number. For a reduction reaction, we'll see the opposite. So our product will have a more negative or less positive charge than the reactant. So with this in mind, we're now going to look at oxidizing agents and reducing agents. So an oxidizing agent and a reducing agent is just a species that facilitates a process of oxidation or reduction. So agent, if we think of it kind of like a travel agent facilitates your travel. A talent agent facilitates bookings for acting gigs or whatever you have. So the agent is the thing that actually makes it happen. So when we facilitate oxidation, this occurs via an oxidizing agent. So an oxidizing agent makes something oxidize. If we have a reducing agent, it's going to facilitate reduction. So a reducing agent makes something reduce. So an oxidizing agent will make a species undergo oxidation, and a reducing agent will make a species undergo reduction. Now, when a species undergoes oxidation, this is electron loss. And so to facilitate oxidation, an oxidizing agent gains or takes electrons. Because the oxidizing agent is taking electrons, the oxidizing agent is reduced. We can look at the same thing for our reducing agent. So reduction is electron gain. And so a reducing agent gives electrons to the species being reduced. And because the reducing agent is giving up electrons, it is going to be oxidized. So we're going to look at a really simple example, the reaction between zinc and copper 2+ to form copper solid and zinc 2+. So in this reaction, zinc is giving up electrons to become a cation. So we could rewrite zinc's half reaction as zinc to zinc 2+, and it will have given up 2 electrons to form this cation. Because zinc is therefore oxidized, it's losing electrons. Zinc is the reducing agent in this reaction. If we look at copper, copper goes from 2+, so a cation, to copper solid, a metal. So copper has to gain electrons to go from cation back to elemental metal. It's going to gain 2 electrons. And because copper is reduced, it is the oxidizing agent. In your Chemistry 30 data booklet, on page 7, there is a table of standard electrode potentials. We'll be using this table extensively in this outcome, but what's important to look at is each half of the table. So the table shows reduction. So going from left to right on the table is a reduction reaction. Reading from right to left on the table is an oxidation reaction. So we have the two-way arrows to show us the reactions can be reversible. Because left to right is reduction, the left-hand side of the table, so if you were to imagine putting a line down the middle of the table where the arrows are, the left side of the table is oxidizing agents. So these are species that are going to gain electrons and be reduced. On the right side of the table is reducing agents. These are species that are going to give up electrons and be oxidized. We'll use this table a lot and talk about how to interpret various parts of it, but this table is helpful to kind of see trends in what types of species tend to be oxidizing agents and what types of species tend to be reducing agents.